Thanks a lot for, first of all, to give you the opportunity to give a presentation about this interesting topic. And thanks also for the nice introduction about my work so far. So today, I want to tell you a little bit about artificial intelligence and extended reality in chemistry, and probably giving you some ideas about the future. And because I think everywhere, when I see that in the kind of camera options over here, you have nice weather. And therefore, I would like to take you also to a nice place and take you to California and show you this nice picture about the coast of California. There's a good reason to show you this. Well, this is a typical picture of like a guy's picture, macho picture about having a sports car and so on. But there's a good reason for that, and that was when I was visiting September 2023 San Francisco, and I was there for the ACS meeting, which I will talk about in a moment. But the interesting thing was, while I, as probably 99% of all people think they're perfect drivers, I had to learn my lesson that I was probably not the perfect driver in San Francisco, because I was really amazed and flashed that the self-driving cars were all around there. There was Waymo, the Google company. And I must admit, despite having this nice sports car and going around with my son and using Google Maps, the Waymo cars were much, much better in driving around in San Francisco, which is, I think, not easy. And to see the cars without a driver was really amazing. Also, though, what AI can do now, I never thought I would be alive when this actually happens in our world or so. And so to see this actually in a real place in San Francisco was amazing. I was trying myself to hop onto one of these cars, but I could not, because you need an app for that. But after coming back to Germany after quite some time, actually we now have the opportunity in Darmstadt. You can hop on one of these cars, and I finally made it. Not in San Francisco, but I these cars, and it's amazing to see that this works so fine, and that definitely. I'm pretty sure I can say that they're driving better than me, which I hate to admit, but that's definitely is the case, or so that this is going to happen in that, and it's amazing. Anyway, with this already kind of triggered when I was there, I told you that I was at the ACS meeting in fall 2023. And before I go on to talk about that meeting, I would like to point out one important thing, because the American Chemist Society has this nice logo over here. And what many people don't know, that this nice little thing which is in the logo over here, that actually comes from our university. That comes from the Justus Liebig University, because that's where it comes from. This is the 5-bulb Kugelrohr. And the 5-bulb Kugelrohr was used by Liebig and kind of invented or created by Liebig for elemental analysis. And it also was that this bird up here, it's not an eagle, but most people think it's Phoenix rays from the ashes, because it's from the elemental analysis. And it's always funny to talk to chemists from the US, because they have no idea where the logo came from. So this is always something also which I really like to talk about. And coming from the lab, from experimental data, and then you have what we were talking about, Chemotion, so bringing things to the lab book. The ACS meeting was about, the theme was harnessing the power of data. And there was also like a full day about different things. And also Jochen Ortmeier actually held a talk there. So I attended this talk, and it was about several things, what was going on. Even more people, I think Sonia was attending online. So several people were actually joining on that. But I was quite impressed, because besides the talks and like from Jochen or so that I knew a little bit about, there was one talk which really impressed me, and that was by IBM. And the talk was about the lab that learns. And this was something interesting. There's not much information you find about that, but you can just go to Google and hit lab that learns and go onto that. I also put up the link to that you can just look into, but I think you find it easily. And there was a talk about that, and what I got was there's a video you can watch also, which gives some information if you go on that page. But I would like to put your attention to this over here, and that was kind of the abstract what they had for their presentation. And I don't want to read the whole thing, but it was like learning from laboratory data at scale poses a bottleneck in research workflows. To overcome the bottleneck, we consider and propose solutions to the fundamental questions: who captured the data, what data was captured, and so on. Electronic laboratory notebooks, ELNs, have traditionally been used to record answers to the above questions, however, they impose the heavy burden on the researcher by requiring manual data entry. In addition, the records do not include information about the environment and so on. And so they did not only have the talk, the presentation, But they also had on the exhibition at the ACS, you actually could join them, and they showed you what they actually meant. And what they did was you got a pair of safety glasses, and on the safety glasses, right in the middle of the safety glasses, there was a very small camera, and the whole thing was attached. I don't recall exactly how they did this. It was a prototype, but it was attached to a computer, to an electronic notebook. And what I could do was I could weigh something and also could do a pH measurement. And it was immediately, once the balance was okay, once the pH was steady, it took the data automatically and put it in the electronic notebook. And that was quite impressive. And so what you can do is actually, you could do an automatic data collection without writing down stuff. It could be, like I said, weight of the sample, pH value, or whatever you took, you could put it over there immediately. And what I think is really nice, you can also immediately take some photos what you're doing, or even take a video of experiments. And this is especially, I think, is something which is really nice if you would get into your lab book also a video of what you're actually doing. I think several of you who are probably group leaders know that your coworkers probably tell you what they did, but sometimes stuff is missing. And to find out really what was going on or where probably was the mistake, you either have to attend the experiment in the lab, which I usually did a couple of times, or if you see the video, it helps you also to find out that everything is okay in that way. You also can record audio, for example, that you just, if you do something, you can say what you're doing or what probably is a problem while you're doing it. You can record all of these things. And many, many other things are possible also to really take part on that when you do the experiments. And all doing this data collection automatically is, I think, quite helpful for putting this also into the ELNs in there. Before I move on, I would like to go into a little bit of my own short history, which is a long history by now. As Sonia pointed out, it was that for a long time I'm trying to work also on modern ideas, trying to do for teaching or also for research. And I always remember when it's a long time ago, 1985, I was in Frankfurt at a GDCH workshop about computer usage in chemistry. And it was amazing. The old professors over there were bitching on the poor presenters over there that we don't need a computer in chemistry. The people should work in the lab. This is all nonsense. There's no reason to use a computer. This is stupid gameplay. The computer never will learn to play chess. It's all nonsense. It was going on and on like this. And yeah, as you know, this is completely many misconceptions. When I started in Gießen, this was kind of also the beginning of something like virtual reality or so, but on a very early stage. This was like the start of Second Life, and I was trying to work on that. But at this time, the internet was much too slow, and it was kind of no fun to really do that. But we really got into more digital work when, after about 20 years of already that clickers were used in the US for teaching. And we also were trying to use them, but it was too expensive. And we thought we should do this electronically by using all kind of electronic equipment. And we had finally from the Technical University in Gießen, they developed a feedback system called Ars Nova, which is now Particify. And we were the first, I think, worldwide actually to use it on a larger group of students, that we could do this and using it with lab books or also with notebooks. And laptops and also with smartphones. And again, I was told that at this time, a little bit earlier, we started with this, that students would never be able to have smartphones. They are much too expensive. No student would ever be able to buy these because they're too expensive. So you see all these kind of ideas about to foresay what's coming up was wrong. We also did very early video recording of lectures since 2011, first with Boinks TV, then it's called Momo Live. We used an iPad. We did videos in books of what we did. We started electronic exams, which was quite a hassle, 2010, with putting all the computers into the library or so on, but we did this. And really getting into virtual reality and augmented reality, I jumped into that 2016 when it was possible really to work on headsets for that and working on that. The reason I tell you that is that it's interesting also how many misconceptions we are taken in that. And when I want to talk about the extended reality today, you should keep this in mind, because again, if you listen to people, the Apple Vision Pro is much too expensive. Nobody will get the headsets and so on. So keep this in mind before you start thinking about that. And then, yeah, since 2002, I wanted to have an electronic notebook for my lab. And it did not work out. I was using Chem Office at that time. It was, I think, called Chem Finder, what you could use. And it was really bad. It was too expensive. And I tried several ELNs. Many of them did not work out. Either they were only for one platform or they were just for um, not really working very well. And then I got, first time we got something that looked pretty good was by Felix Rodolfi, who started with this at 2011. I think I got to know the psi formation at 2018. And then I learned about ChemMotion 2019 at the IOPAC in Paris. And since then, we're trying to use it. And it's very, very difficult still to convince people that they should use electronic notebooks. And I think I would like to say, I appreciate very much that here are many people who are trying to push on that because it's more than time to do this. And if you look at this, 2002 was when I was trying to start on that. And finally, short before I retire, we have really a good electronic notebook or so, which is kind of depressing, but sometimes it takes a lot of time before we really get there. Okay, with this, I would like to come now. I mentioned the IBM headsets or classes or so that they're using, and I would like to jump now to what actually exists right now. And I show you here two headsets or classes. On the left side, it's already 3 years old or so. These are the called X-Real classes. You can buy them for starting about, I think, 400 euros. And on the right side, it's the Apple Vision Pro. And with these, you can do augmented reality. On the left side, the ones with the X-Real classes, it's only for augmented reality. But the Apple Vision Pro, it's possible that you do virtual reality and augmented reality. It's called now extended reality because you can really mix the things in most of the time. So it's not only one of them, but it's a lot of times headsets you're using, you can do both. And so far, this is people talk now about extended reality and usually don't differentiate too much anymore between virtual reality and augmented reality. In augmented reality, I think all of you know about, well, there was just 30 years of Pokemon, but much more recently, there was Pokemon Go, where you could play around. And my son liked this a lot also to play around. And if you see, this is in front of our chemistry department. And it's amazing how good the stuff worked already. I was playing a little bit with my son together because I was so fascinated about that the stuff integrates perfectly well in our environment. And you would think, besides that, you don't see these Pokemon in reality, but you know that this is so real that you think it must be there in a way. And you can use this naturally also. That was kind of an idea what we could do with this. And one of the things I'm doing, at least I'm working with, and I also use some in some cooperation to do this, is that we can go, this is the Apple Vision Pro now. This is in my home office, which you can recognize by the disorder in there. And if you start, you can look, for example, I'm sitting in my chair, and then I'm looking into like a nice protein structure. And while you see this flat on the screen, I see this three-dimensional. I can blow this up. I can immediately go into the active center of the enzyme and can play around with it. And it's pretty amazing what you can do on that. And this is the program what I'm using here. That's called NanoMe, and I can recommend just to try it out one time. You can also do it on the computer, but it's much more interesting to do it in 3D, really in a headset. And what you can do with this is you can load up 3D models. For example, you can load up directly data from the protein data bank. I also loaded up my own crystal structures, so you can use the CIF files and can load them up and can look at your crystal structures. You can build yourself molecules in there. You can explore structures, and you can modify structures. For example, if you have the whole thing in a kind of the most expensive version, it's hooked up to a server, you can take a protein, can take out some amino acid and put another one in there, and your server is calculating in the back or so the new structure. There's kind of fascinating things. And there was a group working on coronavirus on that program, and they used it to meet together because you can cooperate. You can meet in three-dimensional ways and can get together, and you can play around with it and really can make a big use on that. The other one is a nice program which I would recommend, what you could play around with these. You can play around with these all for some of them you can play around for free. Some of them you can, for a short time, you can play around for free. This changes constantly about the pricing. Jigspace is something which is interesting. It works on the personal computer on Windows. It works also on the Apple Vision Pro, and it works on iOS. And here I can show you again. This is in my room again. And here I took, for the fun of it, I took a Geiger counter with me. And you can see that I have this Geiger counter as a, and just, yeah, have it on my lap here. You can look at it. It's nicely created. You can get these things like this one. I bought this one. And the nice thing, this is augmented reality, as I mentioned. Now, if you hate being in the environment of my room, which needs to be arranged again, you can put yourself, this is the Apple Vision Pro again, you put yourself at the beach. You also get the noise of the waves coming in. And then if you're at the beach here, you can just, yeah, look around a little bit. So you have a nicer working environment instead of, it's my office. So it's just like sitting there and then going again to Jigspace. Hand gestures are enough. And then you go and you can load up again the same Geiger counter over here. And you paste it, you put it then wherever you want. So you can choose the place, and I put it down here. And here it is again. And then I have the Geiger counter again, but now I have it, I can put it on the beach here. That not only works for the piece over here, but you also can use glassware like this Liebig cooler. And you can play around with these, can put things together. This is just one of them, or this is like a little thing. This is playing around, or so Bunsen burner and putting the flask, and the fire is stupid, but it's kind of, I mean, it's sometimes it's fun just to do something so like that. And yeah, with this you can put things together and really start up to make things and put a whole laboratory on the desk. I'll show you that in a moment. And what I showed you right now, that was virtual reality, because now you're in a different environment. Not that around you, what you see, like I said, this was in my office, but I was at the beach. And you can use also for that, if you don't want to buy the very expensive Apple headset, you can take a MetaQuest headset, which starts around 300 euros right now. And with this, you can get into these also virtual reality environments, or you can also go into the augmented reality environment, also with the Quest. And I have a very nice picture. This is a picture from our lab. You can see, if you look down here, let me get the pointer over here. Down here, you can see the yellow stickers on our drawers. But all this equipment, what you see up here, this is not there. This is augmented reality. This is just done by Blender. And it was actually done by students who were fitting this, and it stands here just as a demonstration. The fun part was this laboratory glassware was actually created by the mother of one of our students, who was so excited about this program that she wanted to work with us. So I got even the parents of the students involved in our lectures, which was kind of funny or so to see that. But you can see how it looks like, and what you can do in the end or so is you can create a real laboratory environment. And it's in the end, what you can do is then that you get something like a flight simulator. And like in a flight simulator, you have the environment, you can do whatever you want, and you can test it. And in a virtual chemistry lab or in augmented reality lab, you can play around with it, and you can just do some of these things, testing out what you would like to do in that way. One of the programs, actually it's a platform, one of the platforms where you can do already a few things, but it's not perfect yet, but it shows you the potential of these things besides what I showed you right now. I think the most sophisticated one is right now, it's called Engage. Again, you can try it out and can play around with it. It's working also on the computer, but everything is much, much more interesting if you have three-dimensional ways of so to do that. This here is me in Engage. That's my avatar. So it looks very much like me. And with this avatar, I can go into the virtual environment. And you actually can teach in a three-dimensional room. You can go into a lecture room. I will show you that in a second. But what we are also doing is we work together with students. And for example, I work together with at our partner university in Padua. And here you see the students over there who are all wearing headsets. And Now, I think many of you think you don't want to work like that, and that's true because you don't want to have, I mean, like everybody in the same room with the headsets, because then you can talk to the students. So there's no reason to do that. But this was teaching them how to use the virtual reality headset and to do everything, also how to get in there, how to use the program in there, and so on. And then later on, they can be wherever they want in the world. And we were trying one time to get together with our students so we can actually do a lecture at different places. And it's much more real than instead of like a Zoom meeting, what we're doing right now. We see each other flat on the screen, but in that case, you can really go into a lecture room. And I have the lecture room over here for you. So this is our lecture room in Engage. Looks pretty much like our real lecture room. And unfortunately, I only have this medicine example, but I can show you what you can do. This was one example that you learn how to put up a skeleton, and to make it a little bit more funnier, so it's first dancing a little bit around. But then you can see you can play around, you can put on together one of these, you can use the bones, put them together, and you can learn how to do this and you get all the information. You can also draw on the blackboard over there, what I'm doing right here. I had this, we did actually, instead of the skeleton, we could build out a distillation setup, but it's not in there anymore. We lost it, so I cannot show you that right now. You can also do drawings right in the middle of in the air, so a 3-dimensional drawing if you want to. So again, you can see how this works out over here, putting a big question mark in there. And you can also, what you can do is, let me move this a little bit forward so we don't have to, you can go on a whiteboard. So you can also draw on a whiteboard. You can use the camera so you can actually get back outside. Also, you can show something, probably what you want to show. And then you can go back in the lecture room. Now I can transfer myself on the different seats. So I can sit at the back here. You can put up YouTube videos on the screen over there. So this is the YouTube video of our university that I can put up over here. You can use PowerPoints and put them on here, so you can do your lecture in 3-dimensional really nicely. And then you can put also 3-dimensional things in here. Unfortunately, not too many chemistry stuff. You would need a special assignment with a company. We did this for some time, that you could actually load up our own chemistry equipment. But this is like what you see. You can hear it's that you get a skull, and then you can play around with it, and you can do many things with it. You can hand it around, you can give it to other people. And the same thing you can do with molecular stuff, or so that you have, for example, a molecule, you can copy it, you can make it more. And then they have also something which is not too good yet, but it's on their campus, that here they have a test for doing analytics on and getting the flame color here for some of the salts what you have over here. It's not perfect yet, so but it shows you, I think, the potential on that. The other thing what they have is, so more recently, they have AI avatars. And so you can load them up, and then you can talk to them. And you have the chance, for example, to talk to Nikola Tesla, or you can talk I did talk to Nikola Tesla. But I talked to Marie Curie. So you're going into the lab there, and then you get the chance. I think you cannot hear the sound, I guess. Do you hear the sound? No, right? Okay.
A strong acid, usually hydrochloric acid, to dissolve the uranium and other soluble compounds. Next, I used a process called precipitation, adding chemicals to cause the desired radium salts to crystallize out of solution while leaving the other elements.
So it's very interesting. Instead of looking up Wikipedia or something, or Google, you can talk to the people directly and can ask questions. It works pretty well. The only thing I didn't like was you can talk to Aristotle, and Aristotle over there had they had a speaker from India, which sounded really a little bit crazy or so. If you had Aristotle, we would expect that we would have like a Greek accent, and having an accent from coming someplace from Bombay or something like that. That was funny. What I told you today is pretty much, I think, is the tip of the iceberg. What I wanted to show you a little bit about the things, what you can do in AI or using this for different aspects. I wrote an article in Nachrichten der Chemie about these topics. Again, it's only a very, very small part. It just should give you an idea about what's going on there and also probably getting you a little bit excited about what you can do. And for what I would like to close down with is, I think for the conclusion and the outlook, the work in the lab will definitely change a lot. So this is, I think, I'm absolutely sure about that. I don't like to bet anymore on anything because I lost too many times, but it's that you really can find out that there will be a change in the work in the lab because, like what I showed, the classes by IBM, what you're using, or actually the safety classes that are integrated, you will have this with augmented reality, and then you can see how this works. The safety classes will become smart classes that I showed. The automation will come up, so you will have like much more on robotics. It's very interesting what you can do. And we will have virtual laboratories, which is called digital twins. And you can do probably a cooperation direct in the lab so that you have people like Sonia and I, we were working together for a long time. Now, when I'm retired, I probably can join you virtually at one point and jump over into your labs. So in that way, so something like that is possible. Companies like Merck, they were also doing presentations already on like these things with digital twins. They create their labs in parts or so in that way. So there's a lot of stuff is happening in that way that will be very, very different in the future. Also about like how you really do your work. The AI will be there as an assistance. In the beginning, it will be just that you have the stuff coming into your smart classes. So you will have, for example, like I have my classes, and then you will get stuff that you can, for example, you can read the the procedure for your experiment, or you can look up stuff already while you're just doing your experiment. But you also can probably get, like the Pokemons, you will get probably an assistant standing next to you who you can ask and ask questions about what you're doing right now. So that will be something which will be really interesting also in that way. And you can do these things already in a way, and it will get better and better over time. Suggestions I have is that we should keep up on new developments. Not like I mentioned, like in 1985, the professors there who are thinking nothing happens or so. I think this is different now. It will happen. I don't know how many of you know Ray Kurzweil. He was working for a long time, I think, with Google, and then he is somebody who's predicting the future much, much better than other people. And he has written several books, and he had written the book The Singularity is Near in 2007, and now there's a new book out, The Singularity is Nearer. And it's amazing what he wrote in 2007, because it's actually more interesting even to look at the older book, because you find out that he was attacked a lot of times that his predictions would be completely wrong and that is not coming up. And lots of the things he was predicting were correct. So he was pretty amazed also to see that. Also, I would recommend probably to try out some smart classes yourself. If you haven't done this yet, it's at the moment, I cannot even recommend some of these smart classes because there's so many at the moment that are coming up. There are probably about 20 of different brands I know already. One of the most sophisticated right now is from Meta. It's the Ray-Ban headsets, which are also augmented reality classes, but also AI classes. So this is something also it will be very interesting about the competition. Google is getting in there, Apple is getting in there. So this will be interesting also to see who's kind of coming out of that. For virtual reality headsets, it's sometimes funny if your family go to a game center one time to see what actually is working, to find out how immersive this is. This is really amazing. And I can only recommend just to get an idea about that if you haven't done this or so, because it's very difficult to get you excited if you have not done this by looking at the screen. You really have to see how this works if you have to be in the immersive setup, and you really have to practice on that, because you cannot really feel or see that if you're on a flat screen like what we're doing right now. Last thing is, what am I still missing? I mentioned that I was waiting for a long time for electronic laboratory notebooks, and I even miss them right now much more go into retirement, and I'm scanning all stuff what I had like in written, and it's so annoying, and I was like wishing so much that this was already would have been digitalized. But I'm also still missing something, and I have not seen anything like that, as we have now, since a long time, we have tablets or we have the iPad. But what is not working yet already is that I can draw on an iPad or any other tablet, I can draw a chemical structure, and it immediately will digitalize it and put it into ChemDraw or something similar. It works for mathematics, it works for handwriting, but chemistry, it still doesn't work. And I'm waiting for 20 years about that now, that it should work as well. But we cannot do this yet. I hope somebody finally will do that we can draw something and it actually will be digitalized immediately and we can use it. With this, I think I'm pretty good in time. I would like to thank you for your attention. I'm happy to answer questions. And if there are any further questions about some of the equipment and more detailed questions, I'm happy to answer them also by email, or you can call me and I'm happy to answer that. And yeah, hopefully tell you a little bit more about what you would like to know. But thanks again for inviting me. And I hope I could get you a little bit interested in what's coming up and also what you might probably want to use in the future yourself. Thank you.